Let's start by creating a new project in Xcode. So we'll be having the game template. I'm going to call it Flappy Bird Clone. We'll be building it for iPhone, and I'm going to save it on my desktop. So let's set up our project. So the first thing, we need to have it only in the portrait mode. So I'm going to uncheck landscape left and landscape right. Then in our game scene.swift, I don't need to have this default objects. So I'll take all of these things out. Okay, the assets required for this game, I have uploaded it in the resources section, so please download from there. So I'll create a new group for the images. And these are all the images we have, and animated textures for all the for the bird. So, and then the two pipes, one is facing upward and one is facing downward. So let me drag and put it in the images group. And then in the images.xc assets, I don't need this spaceship, so I'll remove it. And then I have this background over here. So that's our background. So we have all the required assets in our project now. So let's quickly run this game and test that if everything is fine. So it takes a bit of a while when you run the game or an application for the first time. So yeah, everything seems to be fine. Our project is running. So I don't need this information for the nodes and the frames per second. So let me take this out for now. So over here, I'll say that I don't need this, and then this as well. So if I run my game again, so this should be going away, and yeah, it is not there. Now let's add the background to our game scene. So let's go to game scene.swift. So over here in the did move to view method, I'll call a method create background. This method is a custom method and doesn't exist yet, but we will create it in a while. Okay. I need to have a variable for the background, so let's create that. So variable background, that's going to be skSprite node, and then I need to give a Z position to my background and other objects. So I'll create my enum for giving the objects Z positions. So I'll call it object Z positions. That's going to be of type CG float. So over here case background, and that's going to be 0. Okay, now let's have this method func create background. So in this one, let's have the background texture first. So background texture, and that's going to be skTexture. Image named, and image is named as background. So now we'll have an action to scroll over background. So variable move background skAction dot move by x, and the x is going to be minus background texture dot size dot width. Y is going to be 0, and duration, say for example 12. So variable, then we need to replace background. So variable replace background, and that's going to be skAction dot move by x, and that's going to be background texture dot size dot width. Y is going to be 0, and the duration is going to be 0. And then move background forever. That's going to be sk action dot repeat action forever, and we need to repeat a sequence which we haven't created yet. So let's create that. Let's call it background sequence, and this is going to be sk action dot sequence, and the sequence is going to be of move background and then replace background, and then over here repeat action forever, we can say background sequence. So now let's have a for loop, so to create a long enough background so that it doesn't go off the screen. So for variable I of type cg float is equals to 0, I is less than 2, and then I plus plus. So background is going to be sk sprite node, and we will call the texture background texture. Then background dot position, and the position is going to be cg point, and for the x it's going to be background texture dot size dot width divided by 2 and plus I multiplied by background texture dot size dot width, and for the y it's going to be cg rect get mid y of self dot frame. Then we can say that background dot size dot height, if it is more or less than the frame height, so then make it equal to self dot frame dot height. Background dot z position, and that's going to be object z positions dot background dot raw value, and background dot run action, and that's going to be move background forever. Okay, so the background will be continuously moving, and also the pipes. So what we will do, we will add all the moving objects to a variable called moving objects, and then we will add that moving objects variable to our scene. So let's have that. So we'll say that variable moving game objects, and that's going to be of type sk node, and then in the did move to view method we can say that self dot add child moving game objects, and this background we will add to moving game objects dot add child and then background. So whenever we need to stop all of these objects, so we can just stop moving game objects. Otherwise, if we don't do it, so then we need to stop all the moving objects one by one. So that should do the trick, and our background should be there and continuously moving. So let's check it out, and as you can see that our background is there and it is moving. Now let's add our bird object to the scene. So for that, first we need to have a variable. So over here I'll have variable bird, and that's going to be sk sprite node. I would need to give bird a z position as well. So let me define all the z position cases over here. So the next thing I'll have for pipes, which we will add in a while. Before the pipes, let's have the ground as well. So ground we will add on the bottom of the screen, and if our bird touches the ground or touches the pipes, so that would be end of the game. So let's give ground 1 and then pipes 2. We would need to have bird, so we'll give it 3, then score, and let's give score a value of 4, and then game over, and let's give a value of 5 to the game over node. So that's our object Z positions. And then we would need to define the contact masks, so category masks, so which is required for the objects in SK Sprite Kit when you're using the SK Physics engine, so to detect whether two objects are in contact or whether two objects are colliding. So for that we'll have a constant let bird group that's going to be of type uint32, and I will define it by a syntax 0 into 1 and then the shift operator and then 0, and then let enemy objects group. So now the enemy objects group will be the pipes and the ground, so and that's going to be of type uint32, and that's also going to be 0 into 1 and then the shift operator and then 1, and then we'll have an opening group, and that would be the opening between the two pipes, and when the bird would be in contact with that opening group, so then we will have our score plus by 1. So that's going to be of type uint32, 0 into 1 and then 2. So these are our constants which with which we will define the masks. So now let's have we have the bird object. So let's go to our did move to view method, and over there we will add the bird. So we will define the texture, so let bird texture 1, and that's going to be SK texture image named bird1.png, and I'll copy this, paste it 7 times, so we have total of 8 textures, 2, 3 and 4 and 5, 6, 7 and 8, and the same goes for the image name. So we have the textures now. So now we will create an animation. So let fly animation, and that's going to be skaction dot animate with textures, and the textures are going to be bird texture 1, 2, and this is going to be till 8, 4, 5, 6, 7 and then 8, and the time per frame I would say that 0.1 second will be good. And then we need to have let fly forever, and that's going to be skaction dot repeat action forever, and this is going to be fly animation. So let's have our bird node now set. So bird is equals to sk sprite node. So texture, will initialize it with the first texture, and that's going to be bird texture 1. So bird dot position, and that's going to be cg point, and for the x let's say cg rect get mid x, and that's going to be self dot frame, and cg rect get mid y, and that's going to be self dot frame. So bird dot z position, and the z position is going to be object z position dot bird dot raw value, and then bird dot run action, so fly forever, and let's add a key as well to this action, so with key, and that's going to be bird fly. So we will track this key, and then we can remove this action by tracking this key. So that's our bird action. So then we can say that self dot add child, and the child is going to be bird. So let's test our game. So as you can see that our bird object is there and it is flying. So now we need to define an skphysics body for this object. So before we do that, we need to define the skphysics world. So for that, we need to have not for that actually. I was adding actually skphysics contact delegate, but that is required only when you are tracking the contacts. So we're not doing that for now. So in our did move to view method, what we will do, we will simply say, okay, first let me put the comments of physics world. So self dot physics world dot gravity, and I'm going to have a custom gravity. The default is 9.8. so CG and then vector make. For the X I'm going to say 0, and then for the Y I'm going to say -15. So I'll define that contact as well over here, though we will be tracking the contacts later on. So self dot physics world dot contact delegate is going to be self. So this is going to give us an error because we haven't told our scene that this is going to conform to skphysics contact delegate. So skphysics contact delegate. With this our error should go away. So now once we have the physics world gravity, so before we add the bird to the scene, so let's say that bird dot physics body, and that's going to be skphysics body, and we need circle of radius, and that's going to be bird dot size dot height divided by 2. Then bird dot physics body dot category bit mask, and that's going to be bird group. Then bird dot physics body dot contact test bit mask. So we need to track the contacts with the openings and or enemy objects group. So we can have the pipe symbol over here if we need to have the multiple groups. So that's the contact bit mask. So then I need to say that bird dot physics body dot collision bit mask, and that's going to be enemy objects group. So when we define the collision bit mask, so that means that both the objects would collide with each other and cannot pass through. But whereas the contact, there the objects can pass through. So now bird dot physics body dot allows rotation. So I don't want my bird to trip over. So for that I don't want to have it rotate when it collides with any of the objects. So for that I'll say that this is going to be false. So if I test my game now, so our bird immediately falls off the screen, because the reason is now we have defined the gravity for our world, and the gravity is -15. So in that -15 means in the downward direction, and the bird immediately gets affected by the gravity and goes off the screen. Now let's add the ground. So for that, the first thing is we will have a ground node. So let's add it over here. So variable ground, and that's going to be sk node. So we'll say that ground dot physics body, and that's going to be skphysics body, and let's have a rectangle. So rectangle of size cg size make, and the width is going to be self dot frame dot width, and let's have the height only 1. Now ground.physicsBody.dynamic, and that's going to be false. So what does it do? The dynamic property. So now our ground, we don't want the ground to be affected by the gravity, so the ground would stay wherever we would add it to the scene. So that's why we have set the dynamic property to false. So now ground dot position, and the position is going to be CG point, and for the X I will say CG rect get mid X self dot frame, and for the Y 0, that means right on the bottom of the screen. Okay, so now ground dot Z position, and that's going to be objects Z positions dot ground dot raw value. So ground dot physics body dot, let's have the category bit mask, and that's going to be enemy objects group. So ground dot physics body dot collision bit mask. So collision is going to be with the bird group, and then ground dot physics body dot contact test bit mask, and that's going to be with the bird group. And then let's add self dot add child ground. So now the ground is there, which is not visible, but it's having a physics body. So once our bird falls, so the ground should stop it. So let's see if that is the case. And as you can see, now the ground has stopped the bird. Now let's load the pipes, which would be coming on regular intervals. So for that we will create a timer. So in the did move to view method, we will create a timer. So variable, let's call it pipes timer, and that's going to be ns timer dot schedule timer with interval. So the timer with interval, so let's say we want to create the pipes every 2.5 seconds. Target is going to be self. Selector is going to be, let's say, load pipes. User info is going to be nil, and the repeats, yes, we want this timer to be repeated. So now we need to have this load pipes method. So let's have that. So func load pipes. Okay, over here we will track that how many pipes have been spawned. So for that we will need to have few global variables. So let's come on the top and over here. So we'll have one is pipe speed, and that's going to be ns time interval and 7. So okay, this is going to be of type ns time interval, and let's initialize it with 7. So that's going to be the speed with which the pipes would be moving from right to left of the screen. And then let's track how many pipes have been spawned, and that's going to be int, and let's initialize it with 0. So now in the load pipes method, we will say that pipes spawned whenever this is called, so make it plus equals to 2. So why I'm tracking the pipes spawned? Because then I'm going to increase the speed of the pipes. So after every 10 pipes spawned, so if pipes spawned %10, that's a modulus operator, equals to 0, so that, and then pipe speed minus equals to 0.5, so make it 0.5. So in that way we will be making our game tougher by the time if you play more. So now let's create a constant gap, and that's going to be of type cg float, and let's call it bird.size.height. multiplied by 3.5. So say for example that's the opening between the two pipes. So then let pipe 1 texture, and that's going to be sk texture image named pipe1.png, and I'll copy this and paste. That's going to be pipe 2, and this is going to be pipe 2 texture. So now we have the two textures. So now we can have our pipe nodes. So variable pipe 1, that's going to be sk sprite node, and the texture is going to be pipe 1 texture, and then variable pipe 2, and that's going to be sk sprite node with the texture pipe 2 texture. Okay, now let's have a random y. So let random y, that's going to be cg float, and we'll have cg float. So arc for random underscore uniform, and then u int 32, and over here we'll say that self dot frame dot height multiplied by 0.7. You can check it, test it, and have it as you want. So that's my random y. So pipe 1 dot position, and that can be cg point, and for x I'm going to say that self dot frame dot width plus pipe 1 dot size dot width, and for the y I'll say that pipe 1 dot size dot height divided by 2 plus 150 plus random y, and then plus gap divided by 2. So that's how I've calculated the y for pipe 1, and then for pipe 2 that would be relative to pipe 1. So then pipe 1 dot physics body, and that's going to be sk physics body rectangle of size pipe 1 dot size, and then pipe 1 dot physics body dot dynamic, and that's going to be false because pipes are going to stay at their position. They should not be affected by the gravity. And then pipe 1 dot physics body dot category bit mask, that's going to be enemy objects group. Then pipe 1 dot physics body dot collision bit mask, that's going to be bird group. And also contact test bit mask, that's also going to be only bird group. So let's have the z position. So pipe 1 dot z position, and that's going to be object z positions dot pipes dot raw value, and then we will add it. So moving objects dot add child, so pipe 1. Now we also need to define the actions to move the pipe. So let move pipe, and that's going to be sk action dot move to x, and let's say we want to move to pipe 1 dot size dot width, but it is negative, so that would be on the left side of the screen, and the duration is going to be pipe speed. So now let remove pipe, and that's going to be sk action dot remove from parent, and then I can say that pipe 1 dot run action, and the action is going to be sk action dot sequence, and the sequence is going to be first move pipe and then remove pipe. So that was pipe 1. So we can test it till this moment. Like we're having an issue over here, and it says cannot invoke argument minus. Okay, this seems to be this should be fine actually. ns time interval, so duration is going to be pipe speed. So I'm saying move to pipe 1 dot size dot width. Okay, let me write it again. So let move pipe, and that's going to be skaction dot move to. Alright, so yeah, we actually had the wrong method. Move to is expecting a location CG point, whereas we want to do it move to X. So that was the problem. So minus pipe1 dot size dot width, and duration is going to be pipe speed. And let me take this out. So it should be fine. And if I run my game now, so pipe1 should be coming on the screen, and as you can see, and then it's getting different position on the screen, and over here it's really on the top. So now let's take care of pipe 2. So for pipe 2, we'll say that pipe 2 dot position, and the position is going to be CG point. And for X, I'll say self dot frame dot width plus pipe 2 dot size dot width. And for Y, that's going to be minus pipe 2 dot size dot height divided by 2 plus 150, and plus whatever the random Y was, and then minus gap divided by 2. So now pipe 2 dot physics body, and that's going to be SK physics body, rectangle of size, pipe 2 dot size, and then pipe 2 dot physics body dot dynamic, and that's going to be false. Pipe 2 dot physics body dot category bit mask, that's going to be enemy objects group. Pipe 2 dot physics body dot collision bit mask, that's going to be bird group. And the contact test bit mask, that's also going to be bird group. So pipe 2 dot z position, and that's going to be objects z positions dot pipes dot row value, and then we will add it to the moving game objects dot add child, and that's going to be pipe 2, and then we will run the action. So pipe 2 dot run action, and that's going to be sk action dot sequence, and the sequence is going to be move pipe and then remove pipe. So now let's test our game till this moment. And the pipes would push our bird as well off the screen, and now you can see that we have the pipes in the top and bottom there, and at both the places, and then there is a constant opening, and the moment the time passes, so the speed of the pipes would increase, and then that would make our game a bit tougher by the time you play more and more. Okay, now once we have the pipe, so we can have the opening as well, which with which we will then track that if our bird is in contact with the opening, so that means that it has passed through the pipes successfully, and then we can add the score. So before we actually add the opening, it's very good while we are designing the game, so that we turn on the physics bodies boundary. So how we can do that? So sk view dot show, that was one second, what was that? Yeah, shows physics, and that's going to be true. So with this one, it would show us the physics bodies in the scene. So as you can see now, this is a circle, that's the physics body, and then for the pipes as well, you would be able to see that there is a surrounding box, and that is the physics body. So now once we will add the gap, so then we will be able to see that where the gap is. So let's go back to our game scene. Let's take care of our bird movements, that the flying of the bird with the with the tap on the screen. So whenever we touch on the screen, so then the bird should move a bit on the upside. So that we will do with the help of the impulse, apply impulse force. So let's go to our touches begin method, and here also we will do this only if the game is not over. So for that, let's create a variable. So we'll say variable game over, that's going to be of type bool, and let's initialize it with false. And now in the touches begin method, we will say that if game over is equals to false, so in that case, then what we want to do, we'll say that bird dot physics body dot velocity. So whatever the velocity is, first make it 0, and the velocity is a vector, so we'll say cg vector make 0 and 0, and then bird dot physics body dot apply impulse, and the impulse is going to be again a vector, so cg vector make, and we'll say 0 in the x direction and 60 in the y direction. So let's test till this point. So now if I click, so as you can see that I'm able to have my bird move up whenever I click. Okay, so let's do one more thing. So when our bird is moving up, so we want to have its face rotated a bit on the upside, and when it is coming down, so we want to rotate it a bit on the downside. So let's take care of that. So we will have an action, so let rotate up, and that's going to be sk action dot rotate to angle, and the angle is going to be, so for example 0.2, and the duration, so for example we want to do it in 0 seconds, like we want to do it immediately. And then we will say that bird dot run action, and that's going to be rotate up. And also we want to rotate it down when we are not touching it, so for that we will track touches ended, and in this one let's first track that if game over is equals to false, so then rotate down, and that's going to be sk action dot rotate to angle, and this time I'll say minus 0.1, and duration is going to be 0, and then bird dot run action rotate down. So let's see how this works. And now you can see that our bird is rotating a bit as well, and it looks more attractive. Okay, let me turn this to false, and let's see, let's run our game again. So as you can see that the bird is flying, and also we have taken care of a bit of a small rotation. In our game scene, so if the game over is equals to false, that means the gameplay in progress, so we are doing this. Let's also take care of that if the game is over, so then we need to initialize our scene again, and in fact we have this code in the game view controller.swift, so this is the one. So I'll simply copy it from here, and else we need to do this. So if let scene is game scene dot unarchive from file, so this is giving me an error over here. I just need to unwrap it over here. Let's add some label nodes now to our scene required for the score, for tracking the score. So over here we will have score label node. That's going to be SK label node, and we would also have a variable score of type int, and let's initialize it with 0. Okay, now we will have some game overload nodes as well. So game over label node, and that's going to be SK label node, and then game over status node, and that's going to be SK label node. So now in our did move to view method, let's have our score label node here. The score label node is going to be SK label node font named, and let's have chalkboard SE bold. The score label node dot font size, and the font size, let's say 50. Score label node dot font color, let's have the white color, and then position, and the position is going to be CG point, and for the X let's have it in the middle, so CG rect get mid X self dot frame, and for the Y self dot frame dot height minus 50. Score label node dot text, we can have it 0 in the beginning, and then score label node dot Z position, so objects Z positions dot score dot raw value, and then we will add it to self, so self dot add child, and then score label node. So let's check it if it is fine. So as you can see, now this is our score label node, and it should stay on the top when the pipes are coming and we are controlling it with the Z positions. Now we will have the did begin contact method. So this gives us the contact, which is SK physics contact between the two bodies, and the two bodies are body A and body B. So how we can track it? So we'll say that if contact dot body A dot category bit mask is equals to opening group, or contact dot body B dot category bit mask is equals to opening group, and that would happen only when the bird would fly through the gap. So in that case, let's add score plus equals to 1, and then score label node dot text, and let's have it score. So we should be able to track our score now. So let's test it. So as you can see, now the score is 1 and 2 and 3. So otherwise, else if, we can say that if contact dot body A dot category bit masks is equals to enemy objects group, or contact dot body B dot category bit masks is equals to enemy objects group. So that means that the game should be over. So for that, we'll say first that the self dot physics world dot contact delegate is equals to nil, and then we'll say that moving game objects dot speed, we will make it to 0. Game over, we will set it to true, and we'll say that bird dot remove action for key, and that's going to be bird fly. So game over label node and we will set it to a scale label node, and font named, let's have copper plate dash bold. Game over label node dot font size, let's have 50. Then font color and sk color dot white color. Then we need to set the Z position, and the Z position is going to be game over dot raw value. Then we can set the text to game over, and game over label node dot position, and that's going to be CG point, and for the X we'll say CG rect get mid X self dot frame, and for the Y CG rect get mid Y self dot frame, and then we will say that self dot add child game over label node. Now let's have a bit of an animation on this node. So let scale up, that's going to be sk action dot scale to, and let's scale to 1.5 in duration 2. Let scale, that's going to be sk action dot scale to, and let's have back to normal in 0.25 seconds. So let's scale sequence, and that's going to be sk action dot sequence, and the sequence is going to be first scale up and then scale, just scale. Okay, now we will say that game over label node dot run action, and we will need to have a completion block. So scale sequence, and in the completion block we will have another status label node. So self dot game over status node, and that's going to be a scale label node, font named copper plate, and self dot game over status node dot font size, let's have it 30. Self dot game over status node dot font color, and again let's have white color. Self dot game over status node dot Z position, and that's going to be object Z positions dot game over dot raw value. Then self dot game over status node dot text, and let's have tap to restart, and self dot game over status node dot position, and that's going to be CG point. For the X I'll say CG rect get mid X self dot frame, and for the Y I'll say CG rect get mid Y self dot frame, and also subtract self dot game over status node dot frame dot height, and let's subtract 20 more, and then I'll say that self dot add child, and then self dot game over status node. Now let's add a bit of an animation to this as well. So self let scale up is equals to sk action dot scale to 1.25, duration is going to be 0.5. Let scale back is going to be sk action dot scale to 1, duration is going to be 0.25. and let's wait a bit. So let wait is going to be sk action dot wait for duration 1 second, and then let's define the sequence. So let sequence is going to be sk action dot sequence. So first will be, let's say, wait, then scale up, then scale back, and then wait again. So this would create a 2 seconds wait between the scale up and scale back. Okay, then we can have the repeat action. So that's going to be sk action dot repeat action forever, and that's going to be sequence. And then I can say that self dot game over status node dot run action, and this is going to be repeat. So that's our game over logic. So now our game is complete, so let's quickly test it. So okay, I've passed successfully, and now and here you go. So the game over, and then tap to restart. So if I tap it, so then I start my game again right from the beginning. And if I'm in contact with the ground, so again then the game is over, and then when I restart, so the game is initialized again.